All right, we're going to call this D13V for the algebra class, and it's going to be on the topic, we're going to call it choosing inputs wisely. Inputs wisely. You don't need to have this worksheet or this piece of paper to be able to take these notes, but if you want to print it up, we will go ahead and post it on the website. So, the idea, the goal for today is to when we choose values to use as inputs for a function, so that we can start to see what the graph of the function looks like. Our goal is to be able to choose those values in a smart way. So here's what we mean. If we're looking at the function f of x is equal to 2/3 times x. Yesterday we talked about making a table of inputs and outputs for that function, where you can choose any values you want to for your input. So you could choose 0, 1, 2, and 3, for example. Right, so let's try each of these. If we look at, I'm going to go ahead and make space for myself to do work over here. Beep, beep. If we look at f of 0, that would be 2/3 times 0. So f of 0 would just be, well, anything times 0 is 0. So that's nice. That's easy enough to write down. It's pretty easy to graph, right? It's just that point 0, 0. So let's try the next one. F of 1 would be equal to 2/3 times 1. So f of 1 is 2/3. That's easy to find, right? We can say, okay, so that means we have an input of 1 and output of 2/3. Graphing that, though, unless we make some kind of weird scale here, graphing that's going to be a little bit tricky. We could try to do 1 2/3. We're kind of estimating maybe that's the right value. It's not bad if you just need a quick sketch, but if you need a real accurate graph, that's not going to be a great point for us. Let's try the next thing. We have f of 2 is equal to 2/3 times 2. So here we would have 2 times 2 is 4, so f of 2 would be 4 over, right, 3 times 1 would be 3. So 4/3, which we probably actually would prefer, just because, where is 4/3 on the graph? I don't really know. So we would probably prefer to think about this as being 1 and 1/3. So when our input's 2, our output's 1 and 1/3. And again, we can kind of estimate, right, our input's 2, our output's 1 and 1/3. We can kind of estimate where it is, but it's hard to graph it exactly if we don't have nice whole number inputs and outputs. So let's keep working here, and let's see if we can figure out when we will have whole number outputs. So for f of 3, we would have 2/3 times 3. We could do 2 times 3 and then divide by 3, or we could take that shortcut division. 3 divided by 3 is 1. So we have 2 times 1 divided by 1, which is just 2. So f of 3 is 2. Hey, there's a nice number. So we have an input of 3 and an output of 2. And we can graph that very precisely because it's a nice whole number output. So then the question for us to think about today, and really what our goal is to figure out when we're going to have nice outputs. So let's see why we had nice outputs here. We had nice outputs here, and we didn't have them here because in both of these, when we had an input of 1 and an input of 2, we were dividing by 3. All right? And what we had on top wasn't something that could be divided by 3. When we multiplied by 0, that took care of the problem completely, so that was nice and easy. When we multiplied by 3, those 3's were able to divide out, leaving with nothing but a 1 in the denominator, and that 1, of course, divides and makes a nice whole number. So think about what other numbers would get that 3 to divide out like that. Well, any number with a 3 in it would do that. So we could, for example, look at f of 6. If we had f of 6, that would be 2/3 times 6. We could write, if we think of 6 as 2 times 6, so those 3 are 2 times 3, sorry. So 3 divided by 3 would leave me with a 2 from the 6. We'd have 2 times 2. f of 6 would be 4. And again, that would be a nice number that we could plot. So we'd have an input of 6 and an output of 1, 2, 3, 4. Right? We could also use negative numbers like -3 and -6. Those would also divide nicely by 3. Once we have those things plotted, we can just go ahead and take our straight edge, line it up, and see all of the other values on our graph. You'll notice those 2 points that I had that were fractions are just about in the right place, but they're off by just a little bit. And this is why using fractions is a little bit dangerous, because we were estimating where 1 and 1/3 was. We did a pretty darn good job estimating where 2/3 was, but it's generally speaking just not a great idea to try to graph with fractions unless you're going to be super smart and change your scale to not count by ones like we were doing here, but to count by something like 1/3. But we'll have that conversation a different day.